Hello again, and welcome to another lesson on intermediate programming. And today we're going to talk a bit about errors, about debugging, and also just about how to understand algorithms that might be complex. You will encounter algorithms like the first time you see a complex sorting algorithm that just don't make sense to you. And one of the techniques of figuring that out is called tracing. And that's where we're going to start today is tracing, which involves making a table where you can represent some of the key variables of an algorithm in order to understand what's happening. So you're able to kind of walk through the algorithm line by line. And so here's a simple example of an algorithm. And you don't necessarily know what this does. You might if you look more closely. But this is going to help us to focus in on what tracing is. And so here you can see the simple table. There's really only two variables involved in this algorithm. And this first variable m is 92.801. And so we're going to fill in that first spot with 92.801, and j is starting off at 0. So you'll notice we start off, before we even enter the loop, these are the values. The next entry is going to be after we go through this loop once. And so you can see that j is being incremented by 2, m is being incremented by 3, and that's all that's happening in this iteration. Then you have to see, are we done? Which we're not. So we go to the next iteration of the loop. J becomes 4, m becomes 98, we go down and check j, still not done, iterate again. Now here you'll notice that j has changed, but I've left m blank, and that's because we have this if statement, which is using the continue command. And continue basically just means stop doing anything in this loop and go back and start the loop again. Go back to the beginning of the loop. So j is going to become 6, j is going to become 8, and then the program stops. Okay? So that's sort of the way that tracing is handled, bit by bit. And that's useful for, obviously you can't do this for super complex algorithms without being able to identify the key variables that you want to keep track of. But I even have to do this sometimes when I see something that really is not getting into my thick skull. And so I may have to trace it out a little bit. Second topic for today is errors. And I want you to remember from your introduction to programming that when we're programming, there's three main types of errors that can occur. The first type is the syntax error. And it's the easiest to spot and the easiest to correct, because usually it is a mistake in coding that will stop the program from running. Like an essay that has words that are misspelled or that isn't using the proper punctuation. Those are things that are easy to find, easy to correct. In a good development environment, it will not let you run the program, and it will provide you with helpful tips or possibly even corrections, suggested corrections for what the syntax problem might be. And we'll see some examples of that. The next error is what we call semantic or logic errors, and these are one of the trickier ones to spot. And this is where the program runs, awesome, it's supposed to add two numbers together, or add 3 to a number, and it adds 2 to a number. The program will perfectly run fine, but there's something wrong with your logic. And these are the tricky ones. You could trace through it manually using the kind of example I just gave you. Or if you have a good development environment, you can actually start to debug it live, which is to create spots in the program where you can stop and see what the variables are like. So especially when you get into complex programs and you don't want to pull out the pen and paper, debugging will let you take snapshots and have a look at what all your variables are as you walk through the code. It does that tracing for you. And we're going to look at how debugging looks in one tool, which is NetBeans. But any good tool will help you debug or run through your code. So semantic logic errors, you really need to, it could be that you were looping through one too many times. The best example thus far in our course, those of you who are following along in the course, is the Nicholas Loves Tobogganing problem. Most of you had running programs right away, Many of you never actually solved the semantic problems and you couldn't actually get to the correct answer, even though you didn't necessarily have any errors that popped up, right? No syntax errors. The third type of error is called a runtime error. And it could be that your logic is fine, your syntax is fine, but the program still breaks at some point. And there are reasons why that could break. It could be that you've used up all available memory. It could be that some other portion of your program is running too long. It could be that you have an infinite loop that's using up resources. And that might not necessarily have been a logic error, but it could cause some sort of a runtime error to occur. The simplest example of a runtime error is you ask to read in a number from the keyboard. And you want a number, so logically it's correct. You use the right syntax, but someone types in a word instead. And if your program doesn't gracefully handle that mistake, it will spit out a runtime error saying, yo, I'm looking for a number, someone typed in a word, this is not good. Something broke during runtime. That's sort of what that error is talking about. So now we're going to talk a little bit about debugging. And those of you who have the lessons, you need to kind of go in there and look through them a little bit. But I'm going to run through this using NetBeans. So I've jumped quickly into NetBeans now, and you can see from this program, quite a simple program. It has two variables. It has an infinite loop, and that's just there to help us illustrate debugging a little bit. And we only have two really pieces of work being done. Nothing very remarkable. So the first part of debugging your code is that you can tell the program where you want it to stop. And in NetBeans, you can do that just by left-clicking on the side here. So you can see when I click, it's going to highlight this in red, and that means that I'm going to stop the program at this point. And I can have as many of these as I want. The next part is that because we want to debug, we are not going to be running the program, we're going to be debugging the program. And so I'm going to do that. I could do it from this level, or I could do it from the level of the program, which is probably what we want to do since we have multiple programs in here. So when I debug the file, it is going to go through and it's going to start running the program. It's going to take all the steps that it needs to follow. If there's input, you got to type in the input, and it's going to keep going until it gets to that particular breakpoint that I'm looking for. Now it turns out that, you see, I ran the wrong program. So let's run the correct one. And you can see it stopped right at that spot over here. Interesting thing is down here at the bottom. You still have your output window. So if I had to type in input, I could still do that. But now I have a variables window. And in the variables window, I can start to see all sorts of information. A lot of this information is not particularly helpful to what we're looking for right now. So you'll notice that I don't really see anything useful here. And that's because I haven't actually done anything useful in my program yet. I'm stopped right here at the first line of code. The other thing I want you to pay attention to is at the top. At the top, I now have a bunch of buttons. I can stop my program, I can pause my program, I can continue, which is basically say keep running until the next breakpoint is reached, or I can start to step line by line. I can step over my code, which means that it is literally going to go line by line through my code, or I could step into my code, which means that if I'm calling a method on this line that I'm stopped at, it will actually go into that method, and I can start to go line by line through that method and then come back out, versus just running the whole line of code and going to the next line. So in this case, we're just going to step over, and right away you're going to see at the bottom the variable x is now being displayed, and it has a value of 2. And I can go again. Y now has a value of 4, and I can keep stepping through my code bit by bit like this, line by line, or I could say continue, and continue is going to automatically go through those 2 lines and bring me back up to this green breakpoint. Again and again, you can see the numbers updating as we go through. So that's the basics of one of the ways of kind of debugging, and that is that you can stick some breakpoints at spots where you know the code is not working properly, and then you can start to step through it or observe it at different points. So we're going to stop that, and I'm going to show you a few other kind of techniques with debugging your code. First thing I want to say though is that if you ever lose the debugging windows down here at the bottom, you can always go up to Window, Debugging, and you can look at Variables, and you can also add in, another useful thing to add in is watches. And we'll talk a little bit about that in a second. Stop this. The easiest way to do the next step, which is called a conditional breakpoint, is to have a breakpoint to begin with. Now imagine that I'm having some sort of a problem in a large database, and I'm reading through it, and on the 99,998th line it breaks. The last thing that you want to do is have to start clicking through 99,000 different times until you get to that error. And so there's a way to create breakpoints that stop only when certain conditions are met. And so if you start with a regular breakpoint like this one, then I can right click, I can go to breakpoint, and I can look at the properties of that breakpoint. And there's a couple of properties worth mentioning here. The first is break when hit count is. And what this will allow me to do is it will allow me to say, I don't want to break the first time you get to this line. I want to wait till the 100,000th time we get to this line. And so I could just say break when it gets to 1,000 or 10,000 or 100,000 or however many times I want it to stop. That's useful. Sometimes though, it's even, you can have an even weirder logic error where it's only happening when a certain number is reached, and maybe that number should never be reached in your code and you're not sure how that value is even possible. Well, that's where you can put in a condition, and this is only going to break if x equals a certain number. And you can have whatever logic, whatever Java logic you want to have in here, you can do. And once I click, you're going to see that that symbol has changed a little bit, and if I go to debug, it stopped. And when I go to my variables, you will see that it stopped after going through this loop, 500 or 498 times, and then it decided to stop. And now I can use all the same things. I can start to go one by one through my lines of code, and I can start to figure out what the problem is. So there's actually quite a lot more you can do with debugging, but that's the basics. And you're going to find as you go through any sort of intermediate course, or you start to develop more complex programs, that being able to debug efficiently is invaluable. And it'll often make the difference between a development environment that you like and one that you don't, is how good the debugging tools are to allow you to solve the problems that you're going to encounter. So try to remember that there are a number of different errors that can occur. We can use kind of pen and paper tracing, but there's also a lot of great debugging tools, and we've just scratched the surface of some of those.